So hello Year 10 and welcome back to 2021, a new term and yet things surprisingly familiar to you guys. Back in lockdown essentially, having to learn remotely. Anyway, I thought we would take this week to go back and recap where we are in the course. And as you're probably aware, there are 10 units within your AQA chemistry course labelled C1 to C10, and very roughly, if we split it in the middle, C1 to C5 are tested on paper 1 and C6 to C10 are tested on paper 2. But it's not quite as simple as that, and actually there are some basics that are tested in both papers, and they're mostly within C1 to C3. Anyway, the units that you have done so far, you did C1, atomic structure in the periodic table, back in year 9. You then went on to have a look at C9, which was a very short one, chemistry of the atmosphere, before starting on C7, which was organic chemistry, and that was done primarily because those bits can be done without needing practical work, lots of practical work. So we then, in year 10, we finished off C7. We then went through C2, which was structure and bonding, and we are now working our way through C8. So the idea is that by the end of the year, you'll certainly have covered C3 as well, and you'll probably have covered C4, so you'll be in really good stead for where you're going to be at the start of year 11. But I thought right now it would be quite good for us to go back and just make sure that you are familiar with the topics you've done, because as I've said many times in lessons, the chemistry topics are all interrelated, and just because you've done a couple of them doesn't mean you can consign them to the bin for the next year and a half until you have to revise them. So today we're going to go and we're going to have a look at some questions from C1 and C9, with the intention that if you do still know the material, great, but if you don't know the material, then you need to go look it up and make sure that you revise those topics. So, starting with C1, atomic structure in the periodic table, we looked at the electron structure of atoms and the number of electrons in the outer shell. So fluorine's got 1, 2, 3, 4, 5, 6, 7, for example, in the outer shell. You also looked at the history of the atom and how the atom was put together and the various experiments that were done and the various scientists involved. And you looked at the history of the periodic table and how that was put together. And again, you need to know something about Mendeleev and Newlands. So here's your first question. The plum pudding model of the atom was replaced by the nuclear model. The nuclear model was developed after the alpha particle scattering experiment. Compare the plum pudding model with the nuclear model of the atom, 4 marks. Now this word compare here says ideally we want to find some similarities. Can we find 2? And 2 differences. And I reckon if we can list 2 similarities and 2 differences, we are on for 4 marks there. Okay, but remember, compare is always similarities and differences. If you remember the alpha particle scattering experiment, the plum pudding model and the nuclear model, why not go ahead and tackle this directly? If not, you need to do a quick bit of revision, use your revision guide or your notes in your exercise book to recap these. Pause the video, 4 minutes, see what you can do. Okay, so hopefully you've used those 4 minutes wisely. So as it shows here, scientifically relevant features are identified. The ways in which they are similar and different is made clear. That's what you need for 3 or 4 marks. So what are the similarities? Well, let's have a think. The plum pudding model of the atom involved negative electrons embedded in a positive pudding, really. So all of this, there's no individual positive bits. The whole pudding is positive with little negative electrons stuck in, like plums stuck in a plum pudding. The nuclear model had positive charge at the centre and the electrons orbiting round the outside. So how are they similar? Well, they both have a positive bit. They both have negative electrons. Neither one has neutrons, and actually neither one has protons either. So neither the nuclear model nor the plum pudding model had the idea of protons. How are they different though? Well, for the plum pudding model, you've got a ball of positive charge which is spread out, whereas in the nuclear model, the positive charge is concentrated at the centre. So you've got to give both of these the contrast for a valid point. For the plum pudding model, the electrons are spread throughout. They're stuck in the ball of positive charge, but in the nuclear model, all the electrons are pushed to the outside. Here's a really important one. In the plum pudding model, there was no empty space in the atom. Whereas in the nuclear model, most of the atom is empty space. And we've talked, haven't we, about the football in the middle of the stadium. And in the plum pudding model, the mass is spread over the whole atom, whereas in the nuclear model, the mass was concentrated in the centre. So I reckon if you've got two similarities, they've both got positive charges, they both have electrons, and two differences, one has empty space, the other one doesn't. One of them has positive charge concentrated in the centre, the other one has positive charge spread. You're probably on for 4 marks. Second question from C1. Describe and explain the trend in reactivity of the alkali metals. So the first thing you've got to do is describe the trend in reactivity, and that's probably worth 1 mark, and then explain it for the next 3 marks. Again, pause the video. If you know how to get on with this, give yourself 4 minutes. If you need to look this up, look it up, and then see if you can work out what the marking points would be for. Pause the video, 4 minutes. See you at the end. Okay, so let's have a look. Well, the first mark obviously is for describing the trend. So for group 1, reactivity increases down the group. Okay? And remember that that is the opposite for group 7. Where reactivity decreases down the group. Well, why does it do that? Well, the first mark is for talking about the fact that at the top you've got the outer electron being quite close to the nucleus, whereas the larger you go, the outer electron is further and further from the nucleus. The second mark is for talking about the fact that the electron is attracted to the nucleus, but because it's further out, there's less attraction. So less attraction between the outer electron and the nucleus. Or there's more shielding. The inner shells, they shield the outer electron. And the final thing is talking about the fact that because these are group 1 metals, they want to lose an electron. And it's much easier for the larger atom because the electron is held less tightly. So it's easier for a large atom to lose that outer electron, and that gets you the final mark. And this comes up quite a lot, so do make sure that you can give these valid points. Final question for C1. A bit that people often forget, transition metals, and you're asked to be able to compare and contrast transition metals with group 1 metals. So some of the properties of two transition metals and two group 1 elements are shown in the table below, and again it says some of the properties, and that is important. Use your own knowledge and the data in the table to compare the chemical and physical properties of the transition metals. Okay, so chemical and physical properties of the transition elements and group 1 elements. And again we've got the compare. Are there any similarities? But certainly, what are the differences? And this time you've got a 6 marker. So 6 minutes. If you need to look these details up before you tackle the question, then do so. But for those of you that vaguely remember this, you've got 6 minutes. Pause the video, have a go, then we'll look at the mark scheme. Okay, so what do I instantly notice from the table? Well, I notice that the melting points are very, very different. So group 1 elements have very low melting points, whereas transition elements have very high melting points. What else do I notice from the table? Well, the fact that these only form one oxide because they only form the 1+ ion. So they form a 1+ ion and that's it. Transition elements, well, chromium here, 2+, 3+, 4+, 6+, 2+, 3+, and here it must of course be something weird because this would lead to 8-, so therefore it's got to be 2 2/3+, okay? Don't worry too much about the details, but what you can see is that the transition elements are forming many different ions. So that's the use the data in the table, and that has got me probably 2 marks out of 6. Well, what else do I know? Well, I know that transition elements form coloured compounds, while group 1 elements do not. I know that transition elements are hard, while group 1 elements are not. I know that transition elements are dense, while group 1 elements are not. And that's probably covered the physical properties. Well, what do I know about the chemistry of these things? Well, I know that group 1 elements are very reactive. Think about cesium, sodium, potassium, lithium with water, very reactive. Think about iron and copper and zinc with water, far, far less reactive. So that's almost certainly covered 5 or 6 marks. So let's have a look. Okay, so we're aiming up here for level 3, a detailed and coherent comparison which demonstrates a broad knowledge and understanding of key scientific ideas. The response makes logical links between the points raised and uses sufficient examples to support these links, and we'll be wanting 6 examples. So, transition elements have high melting points while group 1 have low melting points. Transition elements have high densities while group 1 elements have low densities. Transition elements are strong and hard, while group 1 elements are soft. So we've probably got 3 marks from that maybe. Transition elements form coloured compounds, while group 1 elements don't. Transition elements form ions with different charges. Group 1 elements only form the +1 ion. Transition elements have low reactivity or react slowly, whereas group 1 elements are very reactive. And that's probably the other 3 marks. The one thing we haven't mentioned, but we don't need to do that for all 6 marks, is that transition elements tend to be used as catalysts, and many of these you will encounter throughout the course, but transition elements are used as catalysts, group 1 metals are not. Right, well hopefully those 3 questions have given you an insight into how well you still remember the C1, and hopefully if you've been doing this properly you have gone back and looked at some of that material and you're a bit more confident about what's in that. Having a look now at C9, Chemistry of the Atmosphere, this was done during lockdown and it involved the current atmosphere, the history of the atmosphere, pollutants, and finally global warming. And again, we're going to look at 3 longer answer questions to test your knowledge of this topic. Number 1. When the Earth was formed, its atmosphere is thought to have been similar to the atmosphere on Mars. Explain how green plants and other organisms have changed the composition of the Earth's atmosphere at least 4 different points. Now looking at the chart here, we can see that the majority of the atmosphere on Mars is carbon dioxide with very little nitrogen, very little oxygen. So addressing those 3 points, those 3 gases will certainly get us 3 points. So talk about why carbon dioxide went down, talk about why nitrogen went up, talk about why oxygen went up, and that should get you all 4 marks. Again, if you need to go and refresh your knowledge of this topic, then please do so before tackling this question, but pause the video for at least 4 minutes and then have a look at the answer. Okay, so any of these, 1 mark each. So carbon dioxide, it goes down because of photosynthesis. It also goes down because it's locked up as fossil fuels. It's also locked up as rocks, carbonate rocks. And actually it dissolves in oceans as well. If you've got no life, then this doesn't happen. If you've got no liquid water, then this doesn't happen. Why did nitrogen go up? Well, that came from ammonia in the atmosphere reacting with oxygen. And those things reacted together to give you nitrogen. So methane and ammonia reacted with oxygen, producing nitrogen gas. Why did oxygen go up? Well, oxygen went up because, again, of photosynthesis. So the marks I think you should have got is that the plants take up carbon dioxide due to photosynthesis and give out oxygen. Carbon dioxide is trapped in rocks and fossil fuels. And the 4th mark you may or may not have got, but the fact that nitrogen gas is produced by the reaction of oxygen and ammonia. So if you got that one, very well done. Don't worry so much about the others. Coal is a fossil fuel. Coal contains the elements hydrogen, sulfur, oxygen, and carbon. Name 2 products of burning coal that have an impact on the environment. So we need an impact on the environment. And what impact does each of the products you've named have on the environment? The one I'm not going to let you have, although that is on the mark scheme, which is too obvious, is that carbon dioxide causes global warming. So can you give 2 other products or 2 other pollutants and their effects? If you don't know, look it up. If you do know, pause the video, 4 minutes, off you go. Right, so here we go. The one I didn't let you have, carbon dioxide causes global warming, causes the greenhouse effect, climate change, sea level rise, melting ice caps, okay? Because that is something that you would almost certainly put down, but that is very obvious. and I wanted you to think of the others. So, carbon particles or soot from incomplete combustion, and link this to C7, because you did this in C7 as well. This causes something called global dimming. Blocks out sunlight, causes smog, prevents plants from growing, causes breathing difficulties, okay? So hopefully you guys got that one. Or you talked about carbon monoxide being toxic to humans. So that came from C7, and I'm hoping that you got at least one of those. The final thing, and you really should have got this, was sulfur being discussed. So when you burn sulfur, it combusts to form sulfur dioxide, which causes acid rain. And it's quite important that you remember that, okay? So if you hadn't got that one, I definitely would clock that. Final question of the lesson. The figure below shows a change in mean global air temperature from 1860 to 2000. Explain how human activities have contributed to the main trend shown from 1910 in the figure above. Okay, so 3 marks. So I suspect the first mark is what is the trend? And then 2 marks for how did this happen? Now, notice it's talking about the global air temperature, so make sure you explain why the air temperature goes up. For the last time today, pause the video, 3 minutes, have a go. Okay, so general increase in temperature caused by an increase in greenhouse gases. That's all you had to say here. It could be a longer question, but the general increase in temperature is caused by an increase in greenhouse gases. Okay, so you had to say both of those things for 1 mark, and that quite surprised me. But you had to give 2 different human activities that actually link to a named greenhouse gas. Now the 2 you should always be thinking of is what is causing CO2 levels to go up, what is causing methane levels to go up. Both of these are greenhouse gases along with several other things, but if you know these 2, you will be able to answer the majority of the questions. Carbon dioxide is going up due to burning fossil fuels. And deforestation. And you can talk about like greater population. Methane is going up because more cattle, farty cows, and also due to landfill. So landfill sites release a lot of methane. And if you've got any 2 of those, hopefully 1 from CO2, 1 for methane, that's 2 more marks. Right, I'm hoping that those 6 questions did take you the majority of the hour. Certainly if you've listened to me and then paused the video appropriately for the appropriate number of minutes, that should have taken you almost the hour. Hopefully it has also shown you what you do and don't know about C1 and C9. For the second lesson this week, we're going to go and do a similar thing with C2 and C7. But goodbye for now.